Another topic that is normally covered in the unit of stoichiometry is percent composition. And so if we approach these problems just like you would do a percent in a math class or a percent to figure out how much your clothes will cost at a store, I think it'll be relatively straightforward for us. The big thing that we need to pay attention to in these problems is that we're going to have to do molar mass calculations to be able to figure out what the percent is. We're only going to go over one problem, as a lot of the problems will be self-explanatory once you figure out what your percentages of your elements are. So let's go ahead and go through this, and then I'll give you an example of another type of problem at the end. On your screen, you can see the problem. It starts out with calculate. So reading through that, it says calculate the percent by mass of carbon and hydrogen separately in propane, which is C3H8. And so the first step we need to go ahead and do is figure out the molar mass of propane. So for the molar mass of our compound, we have to break it apart. I'm not going to go over all the steps, but the molar mass of this propane compound is 44.11 grams per mole. The next step we need to do, since we want to figure out carbon and hydrogen separately, we need to figure out how much carbon is in propane for 1 mole of propane. And the same thing goes for hydrogen. So how many hydrogen atoms are in 1 mole of propane? And we'll get the molar mass of those as well. So just as I stated, number 2 says, whichever element is needed for percent composition, calculate the molar mass of that element within 1 mole of the compound. And so you can see here for our propane molecule C3H8, you have 3 carbons and 8 hydrogens. And just to keep both of them going at the same time, I did the molar mass of carbon, 3 of them, and the molar mass of 8 hydrogens, which we will need in our next step. So for this last step, we need to take the number from step 2, and you can see those numbers at the top, and divide it by the number from step 1, which is our molar mass of propane, or whatever compound you'll be looking at. We'll also need to multiply that by 100 to get a percentage and not a decimal point. So let's see how that looks. So up on your screen now you can see carbon and hydrogen, and carbon's on the left, hydrogen's on the right. We went ahead and took our molar mass of our 3 carbons divided by the molar mass of our compound and multiplied it by 100 to get 81.86%. I went ahead and kept 4 sig figs because both of my molar masses have 4 sig figs. I did the same type of work over here, the molar mass of 8 hydrogens over the molar mass of our compound, times that by 100 and got 18.32%. Another way you can think about doing this problem is, once I got my carbon, I could have realized that my percentages always add up to be 100%, which means instead of working through the hydrogen example like I did here, I could have taken 100 minus my 81.68% and got 18.32% that way as well. Now in future problems you might have more than 2 elements within your compound, and that's fine. You're just going to have to do the work for all of those elements. If you're wanting to do that last thing I was talking about, taking the 100% and subtracting the other percentages from that, you need to make sure that you only do that for one of your elements, no matter how many elements you end up having on your list. So at this point in time, this is how you do all your percent composition problems. You could have, a problem where you have the percentages of your elements to start with, and then you'll just assume that you have 100 grams because you have 100% of something when they're all bounded together. Another way you could have the problem is you'd work through this whole problem like we just did, but they'll give you an amount of your compound. So let's go ahead and show the beginning problem again, and I'll give you an example of what I'm talking about. So if we look at the problem that we initially did, calculate the percent by mass of carbon and hydrogen separately in propane, C3H8. You do the same problem we just went through. But then if I said you had like 125 grams of propane, figure out how much carbon will make up that 125 grams, or how much hydrogen makes up that 125 grams. You're just going to figure out the percentage, like we just did, and you'll take the percent, make it a decimal, and take that decimal times whatever amount that was given. So in this case, the 125. You'll have a couple examples to work through in my class that will go through all the different types of problems. So refer back to this problem, as this is the overarching concept of percent composition that will be needed to solve any problem in the future.